Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 11 of the February daily LeetCode challenge, and we again have a question on stack. As I mentioned, yeah, from yesterday onwards, we are going to have from yesterday onwards, we are starting to see questions on stack. This is the second day that we are having a question on stack. Okay, yesterday also we had easy level question, and today we are seeing the first medium level question of stack for this month. Okay, let us quickly see this question again. Like as you know, for stacks concept is very simple. You just have to analyze like where you have to do that push and pop operation, and then you are done. Okay, that is something that is the only thing that you have to find, right? Now coming to this problem, 1910, remove all occurrences of a substring, right? In this, if you see, we are given s, that is the original string, and we are also given a part string. Okay, so if you see the constraints of these two, it is around 1000. Okay, if it had been around 500, then I think they would have given this as an easy question, but since it is around 1000, but like still it is mentioned as hard question. Okay, and if you go to the description, I mean to say, if you go to the description section of the question, you'll see that multiple people are calling it as a hard question. Okay, like not that medium, but yeah, it's slightly hard. Okay, see, there are multiple ways to do it. One of them is a stack. Okay, the other way is like you can even simulate and do that also you can do. And other than that also there are some algorithms, basically even that you can do. Okay, fine. So yeah, let us quickly begin with this question. Given two strings s and r, perform the following operations on s until all the occurrences of the string are removed. Okay, so until all the occurrences of string are removed, we have to perform this. Okay, find the leftmost occurrence of the substring part and then remove it. Okay, we'll see the example I'm open quickly. We'll understand this. Okay, see, first ABC is present. Okay, what we have to do first? The first thing that we have to do is find the leftmost occurrence of the substring part and remove it from S. Okay, so which is the leftmost occurrence of this string? It is going to be ABC. Okay, here it is the leftmost. So you have to remove this now. Okay, as simple as that. After you have removed this, okay, this particular part will be removed now. Okay, okay. Let me do one thing. I will just copy this here and then I will show it to you. Okay, that will make more sense. But yeah, like in the starting, it will not look like it is the right operation, but eventually we'll get to know this. Okay, right. So by the way, like just want to tell you, there is also an algorithm called a KMP algorithm. Okay, that is one of the best algorithms basically for these kind of questions. Whenever there is a repetition happening, for example, if you see here ABC here, okay, there is no repetition, but let us say there are three A's present. Okay, let us say there are five A's present in this part. Okay, in that case, it will not be advisable to do the same repeated calculation again and again. Okay, so what you can do is in those cases, okay, where there are like some high number of repetition of a single character. Or a pattern, in those situations KMP is the best algorithm. Okay, it is slightly difficult one, like if you have to write it from scratch, it will take time. It is basically a linear it's an algorithm which has a linear time complexity. You can just go and study that out basically. Okay, just know the ideas behind that. It's not like you will be expected to code a KMP in an interview. KMP is a very deep algorithm, by the way. It's not something like you can buy hard and code. That is not going to convey any meaning to the interview, according to me. So just know the like logic. Yeah, just know it that yeah, there is a better way to solve this question. Just I want to tell you that. Okay, fine. Now coming to this. Okay, we are in example number one. Okay, so yeah, we have to find ABC. Okay, from the left. So if you see from the leftmost, ABC is present here. Okay, so what I will, just press delete here. Okay, so that ABC is gone. Okay, which is the next ABC? Here it is. Okay, what I will do, I will again press delete, and this also is gone. Again, this is the third ABC. I will do the same thing, press delete, it is gone, and finally this is going to be our answer. Okay, because we cannot find any more ABCs here, and this is going to be our answer. Okay, that is what we have to do in this whole question. Okay, see, like the way that I did, if you try to do in that way, it is going to take around m into n time. Okay, like basically n square time kind of, you can say. Okay, because for every iteration, that is for every time you're going to find it, we have to go through each of them. Okay, something like that. That is, you can call it as a brute phase. Okay, brute force way. But again, there is an easier way to do it, which is using stack. Okay, we'll try to do that. But I will just want to know again, I want to repeat. So you have to find the leftmost occurrence. Okay, then remove it. Okay, after you remove it, some more parts will get joined, and they may also form the same, okay, same substring. Okay, left part. So even that you have to remove. Okay, you have to keep doing that until all the occurrences are removed, and finally you have to return S after removing all the occurrence of part. Okay, okay, they've given the definition of substring here. I've told this thing multiple times in my videos, but again I'm telling you. See, substring and subsequence. Okay, try to learn the differences between them. Okay, if you learn only one of them, you will find the other one very confusing. So keep both of them side by side, then try to learn the differences between them. You will get a better idea in that case. Okay, now how to solve this question? See, as I mentioned, this is a stack question, so we will try to solve it using stack. As simple as, like you have seen my yesterday's video, exact same thing we are going to do. See, I'm creating a stack. Okay. Next, I'm recording the length of both of them. N is going to the length of the part, M is going to length of S. Okay. Now, if N is greater than M, okay, in that case, if you see, See what they're asking basically, you have to remove all the occurrences of part. But let us say part itself is bigger. Okay, see if you see the constraints, there is no mention like what is going to be the length. Okay, like what is the relation between the length of the two? There is no such case mentioned. Okay, they've individually given the constraints for both of them. Okay, but they may not have any relation. So what can happen is a case can come where n is greater than m. Okay, that means the length of the part is much greater than the length of s. Okay, in that case, there is no chance for a part to occur in s. Okay, so you can directly return s in that case. That is what I want to tell you. This is going to be a edge case. Okay, as simple as that. Next, we are starting the simulation now. See, I'm going through each of the characters in S, okay, and then I'm appending it to the stack. Okay, as simple as that. Next, once the length of the stack becomes greater than equal to n, what is n base basically? See, n is going to be the length of part. Okay, once the length becomes greater than equal to part, then we will start comparing. Okay, so after doing the append operation, what I will check is if length of the stack is now greater than equal to n. Okay, if that is the case, check this part also. Take the last n characters. Okay, take the last n characters of the stack. See, first currently they are in a list, right? Now you cannot directly compare them with part. Okay, part is a string, but stack is a list, right? So what we'll do, we'll do this. Okay, we will join the last n elements of with empty string to form a string. Okay, so this particular code basically forms a string by joining the last 10 characters with empty string. Okay, as simple as that. Then once the string is found, we are comparing with the part. Okay, if that matches, that means we have found that, and we'll have to remove that. Okay, so stack is equal to stack of this. So what it means is remove the last n characters. Okay, that is something that I want to do. This is the easiest way of writing it. What we'll do is go from 0 till minus n. Okay, till the index which is denoted by minus n. Okay, in this case, till then go and save it. Rest of the things should be removed. Okay, simple as that. And this is a kind of a pop operation. Okay, we are popping out the last n characters through this. Okay, as simple as that. And again, like this is string joining operation. Here we're taking the last n characters and then we are joining those characters using empty strings. Okay, as simple as that. And finally, like see, this is if condition of that I initially kept it as a while condition. Okay, but then I realized that there is no need of a while condition. That's why I made it as a if condition. Okay, now fine. So this will keep continuing, and finally we are returning. So whatever elements are there in the stack, that you have to join using empty string, and then you have to return. Okay, because you see the return type, it is a string again. Okay, so you have to join them and return that. Okay, fine. Now talking about the space and time complexity, see this is going to be a good one because it's not that simple to predict it, but see what is happening. So coming to time complexity first, see we are going through each element of S. Okay, as the length of S is going to be m, so it is going to O of m solution. Okay, let's O of n. Okay, each iteration is going to O of n time. Now within each iteration, what all we are doing? Okay, first of all, we are comparing the length. This is a constant operation. Then we are doing this part. Okay, and this part will take again O of n time. Okay, what is n? N is going to be the length of the part because we are taking the last n characters of the stack and we are joining them using empty strings. Okay, so this is going to take O of n time. Okay, that is sure. Okay, as simple as that. This whole thing basically, like see, O of n time to make this string and then O of n time to basically compare each character with each character of the part. Okay, all of them, like see, it's not like O of n into n. It's not like that. It's just O of n plus O of n. Okay, now again this part, when you are doing the pop, you're basically going to spend O of n time because you're popping the last 10 elements out. Okay, as simple as that. So again, this is going to take O of n time. Okay, so if you take the combined one, overall all of them are going to take O of n time only. Okay, so within each iteration, basically we are on higher limit taking O of n time. So it is going to O of m into n solution. Okay, if you see, it is going to be O of m into n solution. Now coming to time, sorry, so space complexity part. C, if you see how much space we are going to use, see, let us say in the worst case, none of the parts are present in S. Okay, none of the parts are, not even a single part is present in S. Okay, in that case, the stack we are keep going on appending it, so it will go to the length of m. Okay, it will go to the length of S, which is m. Okay, so this is going to be O of m because stack is going to show m elements in that case. Next, if you see, because of, see here also we are forming a string basically. Okay, this string is of length n. Okay, so this is again going to take O of n space complexity. Okay, as simple as that. Fine. So yeah, these are the two for that reason it is going to O for m plus n. Okay, here we are forming a string of length n. Okay, and then here obviously the stack is going on appending. So overall, if you see, in the worst case, it will be like all the elements will be put in the stack and nothing will be popped out. Okay, so this is going to take O of, okay, the length of the part. So the length of the space is going to O of m. Okay, stack is ultimately going to have O of m, and this string is getting formed, which is going to take O of n. Okay, so m plus n is going to be a space complexity m into n, because see this is O of m. Okay, in that we are basically forming a string which is going to O of n time. We are doing the comparison which is going to O of n time, and then we are popping again going to O of n time. Okay, so all this combined, we are within each loop you are going to take O of n time, and there are m loops. Okay, so m into n is going to be time complexity, and m plus n is going to be space complexity. Okay, so yeah, that was all. Okay, let me quickly run this and show it to you. Yep, as you can see, this is all clearing other test cases. This is one very good test case. Okay, you can take this maybe, and this is not there by default. You have to add it. Okay, see here what is happening. No, after doing this ABC, the last C and the previous B is getting combined and forming the part again. Okay, so here if you see the final output is going to be empty string. Okay, as simple as that. So yeah, and that was all for this video. This was a very good question. According to me, this should have been marked as an easy question, but again, like it depends. Okay, uh, it's not like a simple solution. Okay, you'll have to think of it and then you have to code it. But again, if you know the stuff, if you know it is stack, see, one more thing I will tell you. In my video, I'm from starting itself, I'm saying that it's a stack problem. But if you see the way it is given, you may not realize it is going to be a stack. Okay, because of that reason, maybe it's given as a medium question. Because of that reason, people are finding it difficult to solve. But if you know it is a stack, then I'm sure that this question should be easy. Okay, as simple as that. So yeah, friend, that was all for this video. If you like my efforts, please do subscribe to the channel. This really gives a lot of motivation to continue further. I am trying my best to bring some quality content to you. This is my 112th video. I've done multiple videos previously, but yeah, on the continuous way, this is going to be my 112th video. If you like my words, please do subscribe to our channel. Okay, this actually we are trying to form a community. Like my aim is that, see, I wanted to code every day. I needed a reason to that. Okay, so the reason that I got is that, yeah, okay, I will try to teach the people who do not have access to quality resources. Because of that reason, I started making these kind of videos. Okay, that helps in multiple ways. See, if we are coding alone, that is no one is watching us. The thing is, we will try to, like, okay, if we are able to solve it, we'll leave it. Okay, we'll not try to optimize further. That is not the good thing. But when I am getting a reason to make the video, I have the reason to optimize my code further. Okay, so my aim is always to bring some quality content too. Because of that, I am also getting to learn multiple things. At the same time, I'm also getting a lot of revision for the thing that I have learned previously. So yep, that is my aim. I'm there for that reason I'm doing it. If you find it useful, if you find the content quality one, then please subscribe. And yeah, that's all I have to say. See you tomorrow. Thanks a lot.